Hey guys, what is going on? Welcome to my channel Hairliciously. If you guys are new, I actually had my second hair transplant done in November 2019 at Motion Clinic. So please make sure to subscribe so you guys are updated on my progress as well as on topics covering current hair loss treatments in the pipeline. If you guys are losing hair, visit my website at hairliciously.com where I have microneedling devices that is scientifically proven to stimulate hair growth, my DHT blocking shampoo and serum, vitamins, low-level laser therapy caps, and other products that are beneficial for those afflicted with genetic hair loss. Now, a couple days ago, I had a subscriber who left me a comment in one of my videos addressing concern, asking me to discuss an article that he found online. The article is titled Kyoto University Distributed iPS Cells Found with Abnormalities After Differentiation. Now, iPS cells are known as induced pluripotent stem cells that are derived from skin and blood cells, and they have actually been reprogrammed back to a embryonic-like pluripotent state that enables the development of an unlimited source of any type of human cells needed for therapeutic purposes, including hair follicle stem cells, bone cells, muscle cells, nervous cells, etc. And as you guys are all aware, the holy grail in hair regeneration is the ability to clone and multiply an infinite number of hair follicles from a single hair follicle from the back of the scalp, and then transplanting them back into bald and balding areas using current hair transplantation methods. This is basically what currently represents the ultimate cure for hair loss in both men and women. Now, when we are talking about a hair loss cure and iPS hair-derived cells and human hair follicle regeneration, the first person that comes to mind has to be Dr. Tsuji. And since Dr. Tsuji's hair multiplication involves the mesenchymal and epithelial stem cells derived from induced pluripotent stem cells, the fear of stem cell replication causing abnormalities and cancer has been a big debate over the years. And this isn't something new because even before, even a few years back, scientists and researchers were well aware of cancer-causing mutations found in iPS stem cells. The article, which was actually published earlier this month, states that some iPS cells showed cancer-related genetic and chromosomal abnormalities when differentiated to the target cells. These abnormalities included a genetic abnormality in relation to cancer, while another was based on a numerical disorder in the chromosome. The article doesn't really specify exactly what type of these target cells are, but target cells can include anything, even hair follicle stem cells, muscle cells, bone cells, basically any cell type found in the body. Now, some of the iPS cells, even those produced at the same time, showed various abnormalities while others did not, depending on the research institution they were distributed to, prompting experts to voice concerns over their safety. Now, the issue was that there were no abnormalities in the iPS cells themselves, as it had already gone through multiple genetic testing, but the cells actually developed these abnormalities after being cultured and differentiated. And for those who are not aware of this, cellular differentiation is basically the process that enables one type of cell to another, usually into a more specialized type such as a hair follicle stem cell. Anytime cells are multiplied, cultivated, and differentiated, there is always going to be the possibility of developing an abnormality. So it is very crucial in deciding whether to use a particular iPS-derived cells for transplantation that these companies and scientists carry out experiments to confirm whether they are going to develop into tumors after transplantation into animal studies and check cancer-related genes for each target cell type. And this is where it becomes costly, since cells to be transplanted have to be checked for gene abnormalities before transplantation through a lot of clinical research. And this, I think, is going to be the major hurdle when it comes to stem cell replication and multiplication even to this day. Even if the differentiated cells are detected through sequencing the genome, we still need to keep an eye out to see if they can still cause abnormalities long term. There is a difference in the environment of cells grown in a lab versus in the body, but it still underscores the importance and the need to proceed with caution and care. There's a lot of stem cell treatments out there that have helped various diseases, including bone marrow transplant for leukemia patients, and even in helping repair different types of tissues in the body. But it can also cause different types of mutations, and even years after stem cell treatments. And for example, a 66-year-old man received a stem cell injection in his spine to fix a neurological issue that he was having, and he actually ended up with a growth on the spinal cord formed from the injections. There's another case that investigates a 13-year-old boy who developed growths in his brain 8 years later after attempting to treat his rare genetic disease with stem cells. The issue is that researchers at Harvard revealed that stem cells grown in labs frequently acquire mutations in the notorious p53 gene, which is mutated in over 50% of cancers. And these mutated cells have a growth advantage where it progressively outcompetes the non-mutated cells in cultures. And this is a problem many have even with hair follicle stem cell research and replication, since these stem cell therapies in development involve periods of culture and differentiation where it can definitely increase the likelihood and the odds that it can cause cancer. Now, the problem in the US, particularly with the FDA, is that they don't require researchers to sequence the DNA of cells before putting them into people, mandating only tests required for abnormal chromosomes, which I think is a huge mistake. But I think that this is one of the reasons that Dr. Tsuji is taking caution before announcing anything. And yes, Japan does have an expedited regulatory pathway program for regenerative medicine to allow conditional marketing approval and commercialization while clinical trials continue throughout the later stages. But I believe that Dr. Tsuji is taking the precaution to make sure that there are no abnormalities in the iPS cells themselves by conducting numerous genetic sequencing and testing and analysis before being cultivated, and has been for the last 7 to 8 years since inception of the research. As far as I'm aware, this was part of their protocol by examining the absence of not only toxicity, but also malignant tumor formation from the hair follicle organ base. So to answer, I don't think that this is anything we should be worried about, as it has already been addressed by Dr. Tsuji himself, but it doesn't obviously hurt to be optimistically cautious. And as you guys are aware, human clinical trials in 2019 for Dr. Tsuji has already started, and we are just waiting for the clinical results. So hopefully sometime this year we should hear updates. I still remain hopeful in Dr. Tsuji and his team's research, and I look forward to an optimistic update later this year. I'm not exactly sure what the holdup is exactly, because we haven't received any updates, but there can be several things, including the issues with abnormalities after differentiation from long-term studies. It's also possible that poor hair quality, such as wiry consistency that we saw in the prior mice models, can be the cause, or perhaps they're trying to figure out ways to improve this, or maybe they're trying to figure out the proper hair direction upon implantation. So I'm not exactly sure, like I said, since there hasn't been any updates, but we should hopefully hear from them soon. But even after this becomes readily available, it definitely needs to be well controlled and supervised in a clinical trial for many years. And just because Japan has a expedited regulatory pathway isn't always a good thing, and even long-term side effects of such treatments need to be strictly monitored. So that's pretty much it, guys, for today's video. If you guys liked it, give it a thumbs up. If you guys have any questions pertaining to today's video topic, please let me know in the comments below. But that's all for today, and I'll talk to you guys in my next video. Take care.